Hey everyone, ready for a deep dive into some serious AI breakthroughs. We're going to be tackling a research paper today all about giving those LLMs, those large language models we've all heard so much about, a serious upgrade in the reasoning department.
Yeah.
It's about making them think more like us, like taking their time to actually reason through problems,
Mm.
of just spitting out the first answer that pops into their AI heads.
It's a fascinating shift. We're moving from LLMs, large language models, to what these researchers are calling large learning model.
Okay, LRMs, I like it.
LRMs, yeah.
So is this just like a fancy new name, or is there like a real fundamental difference under the hood?
Oh, there's a definite difference.
Okay, tell me more.
Think of it this way. LRMs are actually designed to think during that whole process of generating an output.
Okay.
They can take extra time, crunch more data, explore different paths to a solution,
Interesting.
just like we do, when we're trying to tackle a complex problem. It's not just about finding an answer, it's about finding the best answer through a process of reasoning.
So instead of that quick Google search for a simple fact,
Right.
it's more like sitting down with a pen and paper to work
Exact.
through a complex equation,
Exact. That's a perfect analogy.
step by step.
And this paper, this research paper really dives deep into how to make this thinking ability a reality for AI.
Awesome.
They developed this approach called RLSP, which stands for reinforcement learning via self-play. And the exciting thing is that it's producing some really remarkable results.
RLSP.
RLSP.
Okay, I'm all ears. Break it down for me. What's the secret sauce here?
Well, the key is, giving these models a way to do what we call guided search during inference.
Okay.
So instead of just generating text, based on the patterns they've seen before, they can actually explore different reasoning paths to arrive at a solution.
That makes sense. I've come across some ideas like self-consistency and process reward modeling, and it feels like those are hinting at this idea of reasoning as a kind of search as well. Right.
But the challenge has always been, how do we build this search capability directly into the architecture of LLMs in
Yeah.
a way that is simple and scalable?
Right.
And that's where RLSP comes in.
Okay.
It provides this clear three-step framework for training these models to reason effectively.
3 steps. Okay, I'm ready. Walk me through it.
All right, so step one is what they call supervised fine-tuning, or SFT.
SFT, got it.
And it's essentially like giving the model a crash course in human-like reasoning
Okay.
by training it on this data of examples that demonstrate sound reasoning processes.
So like giving the AI a really good textbook to study from
Exactly.
before it has to take a test.
Precise.
I like it.
It's about exposing the model to, all these diverse reasoning principles, from backtracking when it hits a dead end to exploring alternative solutions and even verifying its own conclusions along the way.
Nice.
So this initial training phase is really crucial for laying the groundwork.
Makes sense. Give it a good foundation. All right, what's next?
Okay, so step two, this is where things get really interesting.
Okay.
It involves incorporating this reward that encourages exploration.
Okay.
So in traditional reinforcement learning, rewards are usually tied to the correctness of the final answer.
Right.
But with RLSP, they've added what they call an exploration reward.
An exploration reward. So it's not just about getting the answer right.
Exactly. This exploration reward is independent of whether the final solution is correct or not.
Interesting.
It's all about encouraging the model to try different approaches to venture down these different reasoning paths, even if they don't immediately lead to the right answer.
So even if the AI is going down like what seems to us like a rabbit hole,
Uh-huh.
it's still getting some positive reinforcement for that.
Precisely. It's about fostering creativity, and a willingness to think outside the box,
I like that.
which is really essential for any kind of genuine reasoning. It's
Yeah.
like saying, hey, we appreciate you trying different things,
Yeah.
even if you don't get it right on the first try.
Yeah. So we're training the model to be more curious and less afraid to make mistakes
Exactly.
along the way. But how do we ultimately ensure that it learns to get things right?
Right. So that's where the third and final step comes in, which is reinforcement learning, or RL, using an algorithm called proximal policy optimization, or PPO.
PPO. Okay, that sounds pretty technical. What's the core idea behind that?
So essentially, PPO is this iterative process where the model interacts with its environment.
Okay.
It receives feedback in the form of rewards based on both its final answer and its exploration.
Uh-huh.
And then it adjusts its behavior to maximize those rewards over time.
So like a constant cycle of trial and error,
Exactly.
learning from both its and its mistakes.
Precisely. And the key here is that the model is actively shaping its learning process by trying these different approaches and seeing what works best.
Got it.
And this leads us to another really crucial aspect of RLSP.
Okay.
which is this concept of self-play.
Self-play, so the AI is playing against itself.
Yes, it's like having two versions of the model competing and learning from each other.
Wow.
And this self-play aspect is a key driver of those emergent behaviors we were talking about earlier.
Interesting.
It allows the model to constantly challenge itself, discover new strategies, and refine its reasoning abilities without solely relying on external feedback.
So the AI is essentially its own sparring partner,
Yes,
constantly pushing itself to get better. That's
it
fascinating.
is.
But I'm curious, does this RLSP framework actually work in practice?
Yeah.
What kind of results are we talking about here?
Well, the research shows that it's producing some very impressive results. For instance, they saw a significant boost in performance on this challenging math data set called Math 500
Okay.
when they applied RLSP to a model with 8 billion parameters.
Wow.
They even saw improvement on the AIM 2024 math problems using a larger Quen model.
That's impressive.
And what's even more exciting is the emergent behaviors that they've observed.
Emergent behaviors. Okay, now we're getting into the really interesting stuff.
Right.
Tell me more.
So they observed things like backtracking, where the AI would essentially say, oops, wrong path, let's try again.
Okay.
They also saw them exploring alternative ideas, testing different approaches, and even engaging in what seemed like self-verification, double-checking their own work before presenting a solution.
Hold on, that's wild.
It is.
It's like the AI is developing its own internal reasoning strategies. Like it's almost becoming self-aware in a way.
It's definitely a fascinating phenomenon.
Yeah,
And it really speaks to the power of this RP approach.
totally.
And remember, these behaviors weren't explicitly programmed into the system.
Right?
They emerged organically from this training process.
Wow.
It's like we've given the AI the tools to think,
Yeah.
and now it's started to think for itself in ways that we never anticipated.
It reminds me of those nature documentaries where you see like animals solving problems in creative ways that no one ever taught them.
Mhm.
It's like we're witnessing the early stages of a new kind of intelligence emerging right before our eyes.
It's an exciting time to be working in this field, that's for sure.
Absolutely.
And the implications of this research are potentially huge.
Definitely. But before we get too carried away with all the possibilities,
Yeah.
I want to understand why this approach works.
Okay.
Do the researchers have any theories about what's going on under the hood that makes RLSP so effective?
They do, and it's based on this fascinating connection between computational power and the length of the reasoning process.
Okay.
So they propose that the more steps an AI takes in its reasoning, the more computational power it's effectively utilizing.
So it's like giving the AI more resources to work with,
Exactly.
more space to think.
Exactly.
The more likely they are to find a solution.
That's a great way to put it.
Yeah.
And this is supported by the observation that, RLSP trained models often produce these longer, more detailed reasoning chains in their outputs.
Interesting.
It's as if they've learned that taking more steps, even if they seem redundant at first, can lead to these more accurate and robust solutions.
It's not just about having the right answer. It's
Yeah,
about showing your work,
Exactly.
demonstrating a clear line of reasoning to get there.
Exactly.
And that takes computational power.
Oh.
Just like working through a complex equation, step by step takes brain power.
Precisely.
Yeah.
And this has some profound implications.
Okay.
Because if reasoning ability is really linked to computational power, then as these AI systems become more powerful, their ability to reason could grow exponentially.
Well, we're talking about AI that could potentially surpass human reasoning abilities in the not-so-distant future.
It's a possibility we need to consider seriously.
Yeah.
And it raises all sorts of fascinating questions about the future of intelligence, both artificial and human.
This is definitely a conversation that need to continue.
Yes.
But before we get ahead of ourselves, let's take a closer look at the specifics of the research. I'm curious about those ablation studies you mentioned earlier.
Right.
What exactly did they involve?
Okay, so the ablation studies,
Yeah.
these were experiments where the researchers essentially took apart the RLSP framework
Okay.
piece by piece
Okay.
to which components were truly essential for its success.
So it was about isolating the key ingredients of
Ex-
RLSP and seeing if any of them could be removed without sacrificing performance.
Precisely. They specifically wanted to investigate the role of the SFT phase
Okay.
and the exploration reward.
Uh-huh.
Would the model still learn to reason effectively if they were only trained with pure reinforcement learning?
Right.
Without those initial building blocks?
And what did they find? Were those components truly essential?
Well, the results were actually quite surprising.
Okay.
And they revealed some interesting insights into the learning dynamics of different models.
Now you've got me intrigued,
Yeah.
but I have to save that juicy reveal for part 2 of our deep dive.
Sounds good.
I can't wait.
Welcome back. Remember those ablation studies we were just talking
Yeah,
about?
those are the ones where the researchers like take up the RLSP framework piece by piece, right?
Exactly. It's like playing with building blocks. You have this complex structure, in this case, the RLSP framework, and you want to see, how each block contributes to the whole thing.
I like that
So
analogy.
you remove one block at a time and see what happens. Does it collapse? Does it stay strong?
So we're figuring out the essential ingredients, the ones you can't take away without messing everything up. Whoa, did someone just break the fourth wall? Let's hear it.
That's right. It's like finding the essential spices in a recipe.
Okay, so you're thinking,
Yep. Go on. Great question. This paper doesn't explicitly detail training a separate reward model.
but it does talk about different ways to define and implement that exploration.
Exactly. We experimented with a couple of approaches.
Okay, what do they try?
One way was simply to reward longer responses.
So rex q equals ACO, where O is the number of tokens.
Precisely. Longer responses get a higher reward, encouraging the model to show its work.
But they noted that models can hack that reward.
Yeah, they can learn to just repeat themselves.
Right, so what else did they do?
They used an LLM as a judge, like GPT-4o,
To score responses based on creativity and reasoning effort.
ignoring whether the final answer was correct.
So like a thumbs up for effort, not just result.
Exactly. This paper suggests using constitutional AI to train an exploration reward model.
Interesting. Using RL to formulate a constitution.
Right. Then steer the model towards the desired behaviors.
So that's a direction for future research.
Definitely. Now, where were we?
We were talking about these ablation studies.
That's right. Making sure the model is ready for prime time, so to speak.
Right. So for the llama models, it was like taking away a kid's training wheels too early.
Oh, I like that.
They really struggled to develop those search behaviors, those essential steps of exploring different paths.
It was like they haven't built the right foundation.
So for llama, that SFT phase is non-negotiable. It's like a fundamental building block.
It seems that way. It's that crucial first step.
What about Quen? Do they have the same training wheels dependency?
That's where it gets interesting. The Q models showed this surprising level of resilience.
Really? They could just jump right into the deep end.
Even when they were caned with pure reinforcement learning, skipping the SFT phase altogether, they still showed some search behaviors.
Wow. So it's like they came pre-wired with some reasoning abilities.
Almost like they had an innate sense of how to explore.
It seems that way. It's like they had this natural ability to explore different paths, even without that initial hand-holding.
It's like some people just have a knack for directions.
That's a big difference between the two.
It is. It raises all sorts of questions. What accounts for this difference?
Is it the way they're built, the data they were trained on?
Could be their pre-training data included more implicit reasoning examples.
Yeah, it's like each one has its own personality, its own way of learning.
And strengths.
Oh, yeah. Go on.
So our prediction is that RL is more generalized for be better than RL better than SFT. I have a question about the test time compute based on this RLSP framework.
That's a great point. The paper does show RLSP's benefits.
And to your question about test time compute.
How allocating more resources during inference improves reasoning.
Right. They found that scaling test time compute helps.
Especially for those more complex tasks, like math.
So it's like giving the model more time to think through it.
Exactly. Like letting it run through more scenarios.
They point in a study that says test time compute is really effective.
Even more than scaling model parameters.
And that RL-based scaling is important at training scale.
This shows the connection between RL and test time compute.
It's still early days, but those are the findings.
And to come back to RLSP versus other methods,
Those ablation studies we mentioned earlier.
they gave some crucial insights into the exploration reward.
Exactly. That's the reward that encourages thinking outside the box.
Even if it doesn't lead to the right answer immediately,
Exactly. So the question was, what happens when you take that away?
do they become less adventurous?
Well, for the llama models, yeah.
Removing the exploration reward really hindered their search behavior.
Okay, so they need that little push.
They got much more conservative in their approach.
Sticking to well-trodden paths and rarely venturing off.
So for llama, the exploration reward is like a shot of courage.
Or maybe a little dose of curiosity.
What about Quen? Did they still explore without it?
To some extent, yes, but it was definitely less pronounced.
Okay, so they're naturally curious, but need encouragement.
Even for a model with that natural inclination makes a difference.
It's like us. you know, even if we're naturally curious.
Sometimes we need that little extra push to try something new.
But how do we measure if RLSP is more efficient?
And it brings us back to that technique, self-consistency.
Where you ask the LLM for multiple answers.
Exactly, like a wisdom of the crowds approach.
Okay, so how did RLSP stack up against that?
They looked at something called token efficiency.
Token efficiency.
Tokens measure how much computational effort it takes.
Okay, so a more token efficient model can do more with less.
Exactly, like getting more miles per gallon.
I like it.
And RLSP trained models were much more token efficient.
So it's not just about thinking, it's about thinking smarter.
Precisely.
Quality over quantity.
Exactly.
So we've covered a lot of ground here.
Yes, we have.
And hopefully given everyone a solid understanding of RLSP.
Indeed, and how it's helping LLMs evolve into LRMs.
Thanks for joining us on this deep dive.
Until next time.
We hope you learned something new about AI and reasoning today.